Hello everyone, welcome back to the fifth lesson that is on complex numbers and DeMoivre's theorem. This is the last lesson in the chapter 8. Now we will see the learning objectives. We will learn to convert complex numbers from rectangular to polar and vice versa, and find products, quotients, powers, and roots of complex numbers in polar form. Now, first, initially, before we go into the objectives, we will learn about complex numbers. Here the keywords are complex plane, real axis, imaginary axis, Argand plane. So the pronunciation, oh sorry, there's modulus. Okay, so many. Now, modulus is basically finding the square root. It is, I'm sure you've come across this, these two lines. Now, modulus of 4 would be, that's also called absolute value. Thus, this would be positive 4. So whatever is inside modulus, it'll be just positive. It's the distance. The sign is always positive when you put anything inside these two lines. Now, about Argand plane, this is pronounced as Argand plane or Argand plane. So it's up to you. It depends on whichever pronunciation you use. So I'll be using Argand plane. And now we will see about the complex. It's also called as complex plane. This guy is the one who found it is Argand, so that's why it's named after his name. Or you can just use complex plane. Now, the complex plane, the details about it is given over here. I'm sure by reading it you will never understand. It's not easy to understand. It's better we see a picture. You can pause the video, read this, or you can read this later on, which will make much sense. Now let's see what exactly it is. This is the complex plane. This will have an imaginary axis and a real axis. Now the real axis is in the horizontal, that's x-axis. Okay, all the real numbers. Now if you remember the complex numbers, you can write them as a real number plus a complex number, right? A complex number is, sorry, real number plus imaginary number, right? So this plus, say, 2i. Okay, that's already there. Let me take something else. 4i. Okay. So now this is the real part. So real numbers are just real numbers, the counting numbers which you use, 1, 2, 3, 4, 5. Imaginary numbers are all numbers with I. If you have both of them together, it becomes complex numbers. How do we represent it? It is through the Argand diagram or Argand plane or complex plane. Here, imagine this number 3 is somewhere over here. This is the thing. That is the real axis, okay? Now, 4 is in the imaginary axis over here. Let's see where it meets. This is the point. So this would denote complex number 3 plus 4i. That is what this complex plane is about. So whatever the numbers are on the x-axis is real and the imaginary is on y-axis. So now look at this. This is the real and this is imaginary part. So let's solve a couple of problems about it. But before that, let's see about absolute value or modulus. See now, this modulus basically is the distance. Look over here. Algebraically, it's given like this. You might remember distance formula is similar to it. The distance from the center, that is 0, 0, is used. So you will have a plus bi. This is the complex number, right? The coefficient a, square root of that, plus the b square root, the square of a and plus the square of b, the whole square root. So that is what we are doing. It basically gives us a distance from the origin in the complex plane. Okay, so now imagine 3 plus 4i is over here. So the distance, that is square root of 3 square plus 4 square, you'll get something that's 5. That's the distance. That point is 5 units away from 0. I hope this is clear. Now let's see a couple of problems. Graph and graph graphs and absolute values of complex numbers. Sorry, I was just confused over here. Now, graph each number in the complex plane and find its absolute value. You can see z is equal to 4 plus 3i. Now, this is a complex number. How do we graph them? It's very simple. Identify what is A and what is B. A is the real part, B is the imaginary part. So step 1, write AB values. A is 4, B is 3. Step 2 would be graph the given in the Argand plane. That's over here. If you see 1, 2, 3, 4 x, that's the real axis, and 3 in the imaginary axis. You got it. Then you need to find the modulus, that is by the square root. So all you need to do is square root a square, that's 4 square plus 3 square, and that's the answer, that's 5. So that's it. So the absolute value of this is 5. Now similarly, you can try one more problem. The only difference is it's minus numbers over here and minus sign is there. Please pause the video, take time, solve it, and then continue to the explanation. I hope at least few of you tried it. Now let's see the problem. Over here, write A and B values, right? So what do you do is, see what's the A value, that is -2. And then over here there's nothing, only minus sign. That means it's -1. A is -2, B is -1. What next? We can graph it easily. It'll be both in the third quadrant because minus and minus. So -2 over here and -1, this is the point. Now, again, find the absolute value. Just make sure when you're finding the absolute value, use brackets because there's negative. So -2 the whole square plus, again, use bracket, -1 the whole square. Okay, this would be square root of 5, that is 2.24 basically. So this is the answer. Once again, I'll just tell you why brackets are very useful. If you don't use brackets, I'll just show you over here. You may not get the correct answer. -2 square minus 1 square. Now over here you will get a math error because inside the square root the negative sign exists and it's an imaginary number. So it won't be solvable. So that's why whenever you are minus, please use square root, which is very crucial. So you will get the correct answer. We saw in a while ago, I used square roots and we got the correct answer. But I used the brackets and got the correct answer. But without the brackets, you're not getting the correct answer. We will now learn about the argument of a complex plane. Argument means the angle that is created with the positive x-axis. Now, you can see over here, this is the angle theta, right? With the real axis or x-axis, that is the argument. Okay? So the argument of a complex plane is always the angle theta. Now, it is very crucial for us to know to convert complex numbers to polar form. How do we do that? It's very simple. Generally, the form of a complex number is given as a plus bi. We have studied that already. We had seen a few problems already. Now, z is equal to a plus bi. This needs to be written in complex form. In complex form, the formula for a is, in polar form, okay? This is the complex number. We need to write this in polar form. The formula for a is basically r cos theta and b is r sin theta. So it is r cos theta plus b is r sin theta, okay? Then I remains over here. So what happens? R and R is same, so R can be removed out common. And what do we get? Cos theta plus I sin theta. So this is the standard form which we write generally. But remember, this is how we get it. But we don't write all these steps. We just take Z is equal to R cos theta plus I sin theta as the polar form. And you can see the formula over here. A is r cos theta, B is r sin theta. Now this is fine. This is not generally used, only to find this. What are the few important things? R value. How do we find R value? It's basically the modulus, the distance, the radius, right? It's use the modulus. That's it. R is square root of a square plus b square. We have solved problems on modulus, same concept. But only new concept over here will be theta. Okay, obviously this is new, polar form is new altogether, but the formula theta is, the argument is new. That is, we have done this in the previous lessons, tan inverse b by a. Always remember, It varies. Sometimes it'll be only this much. Sometimes you'll have to add pi or 180 degrees. So when do we add pi? So what happens is if the given value of A is positive, if A is positive, it will be in this axis, right? Sorry, it will be the right side. Then this is it. This is the formula. Okay. Theta is tan inverse B by A. But if it goes to the other side, then you need to add pi, that is 180 degree, to the formula. Whenever A is greater than 0, that means positive, this is the formula. If it's negative, that's less than 0, then this is the formula. Let us solve a couple of problems. You'll understand how easy and simple it is. Here we have a complex number. We need to express it in polar form. -6 plus 8i. So the first thing is write the A and B values. A is -6, B is 8. Okay. Next, find the absolute value. That is radius, R value. So R is equal to square root of A square plus B square. We have done this already. Let's substitute the values. Please use brackets when it's negative numbers. So over here brackets are used and put it in the calculator. You will get the answer. Square root 100, that is 10. Okay, R is found out. What next? Now we need to find the angle, that is the argument or the angle theta. Now, which formula do we use? It's minus over here, so remember to add pi. It is tan inverse B by A, that is B by A plus pi, because it's negative, A is negative. Now over here you need to substitute the values and solve. Now there is one important thing which I now remember to tell you about the radian mode and the degree mode. See, till now we always use the default mode of our calculator, that is, see, degree. Now I will solve this in degree. So tan inverse B is 8 divided by A is -6 and close the bracket. I cannot put pi, I need to put 180 degree, but let me put pi now, shift and this symbol. I won't get the correct answer. Okay, why? Because we need to solve it in terms of radians, in terms of radian, okay, not in degree. Now, why I'm avoiding degree over here is generally in your exam, your answers for this lesson will be in radian modes. It won't be in degree. So if you do degree, then again you need to convert it back. You'll get in terms of pi, then multiply the pi and all that. I will show in this problem, even if you do it in degrees, you will get the same answer. But for now, I will tell you the radian method. This is very important. You need to just substitute all the values as it is, but you won't get the correct answer until and unless you change the mode to radian. That is by pressing shift, mode, and press the number 4. And now you can see R sign pops up. That means it is in radians. Now your answer is theta equals 2.21. That is the answer. That is the theta. So in the polar form, that is R of cos theta plus I sine theta, all you need to do is R value is 10, substitute over here. Cos theta is 2.21 and over here sine 2.21. That is the answer. So this is the, sorry, let me go back. This is the answer for the polar form for this complex number. Now, I had told you about degree mode, a degree itself before, and let me go back to the degree, that is mode 5.3, or if you clear your calculator, you'll be in degrees. You must use 180 degrees, okay? You must use 180 degrees. Now, what happens is, this is in degrees, you need to divide 180, okay? Now, this is the radian mode, but now remember, whatever you get over here is in terms of pi. That is 0.704, let me write 0.5. It's in terms of pi, that much pi, you know. So this is the theta in radians, okay? When you convert, remember when you divide, you must always keep this pi over here. Now, if you're solving this, you need to put 0.70, or you can just take the answer anyways, shift pi, and you should press this symbol SD, and now you will get the same answer. So this is a big procedure, right? First, you need to write in degrees, all that. So to avoid this, I'll repeat again, the simplest method would be write the formula, write the substitutions, and feed it in your calculator. That is shift tan 8 divided by -6, close the bracket, and it's plus pi. Don't put in 180, keep it in pi, okay? Plus pi. And now change the mode, shift mode 4. It comes in radians, and this is your answer. That's it. You don't need to do any step further. Even if you do degree, you will get it, but it's a long procedure. So this is the easier method. I hope this is clear. If you have confusion, just go back in the video and watch it again. Okay, we will do one more problem. You'll be clear. Now, please pause the video for this problem and do it by yourself. I hope some of you at least tried it by pausing the video. Now let us solve this. Over here, most important thing is r and theta. That's it. So a value is 9, b value is 7, and look over here, absolute value is square root of a square plus b square. So it's direct substitution. Put it in the calculator, you'll get the answer. Now what next? That is the angle theta. So remember over here the a value is positive, so there is no pi. See, this pi extra was there. Why? Because a was negative in the last problem. In this, it is positive, so no pi. It is just b by a. Let us do this. Tan inverse b by a. What is b value? B is up and then a is down. Solve it up. The answer is 0.661. So just in the calculator. But make sure if your calculator is not in radians, mine is already in radians, it's not going to give you correct answer if it's not in radian. I will just show you. The default mode would be in degrees. This is how your calculator would be. Now if I solve it, look, this is in degrees. I don't want it in degrees, I need it in radians. So shift, put it in 4 and you're gonna get the answer. So now in the polar form, always it's written in radians. So it's r is 11.4, and over here we have cos 0.66, that is in radians. So that's the answer. This is the polar form. And now we will quickly see one last problem in this topic, that is graph and convert polar form of a complex number. Now over here they have given a polar form. We need to write it in the rectangular form. That is just the regular form which we get, right? So how do we do it? This is very easy. So see what is r, what is theta. This is important. But now this is only to draw the graph. If you want a polar graph, this is, it's not okay. They have asked you to graph. If it's not asked, generally if they ask you only rectangular form, this method is not required. This also is not required. It's direct method. But for now they have asked you to graph. That's why r and theta is important. In the previous lessons, we have done this many times, but just the only thing over here is x is the real axis, y is the imaginary axis. What next to do? This r is 3 and this pi by 6 is the angle, so this is the point. Okay, now we need to convert into rectangular form. It's very simple because all you need to do is solve it up. Take out your calculator. What is this? Cos pi, shift, and over here the symbol pi by 6. It's in radian mode, so you don't need to change anything. Only if it is in degree you need to make this 180 degree. Now it's in radian, so it's fine. Use pi as it is using shift and the symbol over here, and you're gonna get the answer root 3 by 2. Same thing, do it for sine. Take this, put sine. Okay, I'll just close the bracket over here. Now it's 1 by 2. So cos pi by 6 is root 3 by 2. Sine pi by 6 is half. Now what you must do is multiply 3 inside. When you multiply 3 inside, you'll get 3 root 3 by 2 plus 3 by 2i. So that is the answer. The rectangular form of this particular complex number, which is given in polar form, is 3 root 3 by 2 plus 3 by 2i. These both are equivalent. This is the polar form. This is the complex form. Now we will learn how to find the product and quotient of a complex number in polar form. Look, let's see two given equations. They are in polar form. These are two complex numbers, z1, z2. Over here in the first case, z1 is having radius r1 of cos theta 1 plus I sine theta 2. In the second case, the subscripts, you can see the subscript, the numbers are all 2 because it's z2. For the product, it's very simple. You must remember product denotes to addition of angles and multiplying. That's it. Z1 and Z2 will be multiply the radii, and for the angle cos theta 1 and theta 2 is added. Same thing, I sine theta 1 and theta 2 is added. Whereas for the quotient, it's division, right? Z1 divided by Z2, divide the radii, R1 divided by R2, but the angles are subtracted, cos of theta 1 minus theta 2, plus I sine theta 1 minus theta 2. Let us look into problems. You will understand how we can solve this practically. Now here, find the product of these both complex numbers which are in polar form, then express the product in rectangular form. So after you find the answer, it's not over, you need to convert it to rectangular form. Let's see. First, use the formula. That is R1, R2. Over here, R1 is 2 multiplied by 4. Cos theta 1 is 5 pi by 3 plus pi by 6. Then plus I sine 5 pi by 3 plus pi by 6. You can't do it entirely. All you need to do is, you need to do it by parts. So 4 twos are 8. It's very simple. You can do it. Now, what about this? It is cos. Okay, it's not done over here by cos, so it's done individually. What they are doing is 5 pi by 3 plus pi by 6. That is shift pi by 6. Now it's 11 pi by 6. So this is in the numerator the pi, so 11 pi by 6. Same thing over here, it'll be pi by 6. Now what you can do is, this is it. This is the answer for the polar form. We found the product, but it's not over in this case. You need to find the rectangular form. How do we do it? It's very simple. Just solve it up now. Use cos. We know the answer is simplified, but I've written the entire thing. What's the answer for cos? It's root 3 by 2. Okay. What about sine? Shift change to sine. It is negative half. So this minus half. Now multiply this 8 inside. Over here, when you multiply the 8, 2 ones are 4s are. So it's 4 root 3 minus 4i. This is the rectangular form. So the polar form of the product is over here. The rectangular form is over here. So these are the answers. Let's see a quotient problem. The product is simple. Now over here, it's a real world problem. If a circuit has a voltage E of 150 volts and an impedance, now you might have come across this impedance in physics already. Impedance means resistance. Impedance Z of 6 minus 3J ohms. Ohms is the unit of resistance. Find the current I in amps in the circuit in rectangular form. Use E equals I into Z. So they have told us the voltage is given, current times resistance, that will be the voltage. So we have to find, the formula is given. What do we have to find over here? They have told to find the current. Okay, what is the other way to find current? So voltage is the current flow multiplied by the resistance, that's the voltage, right? Now, what is the current then? It is the voltage divided by resistance, E by R, or in this case E by Z. So this is equal to I. So basically what you have to do is you need to find the division quotient of E and Z. That is what is required. So over here, write the given. So okay, now when we are writing, see this ohms, that's the resistance, is given properly in the complex form. But what about this? There is no imaginary part. The voltage is only 150. There is no imaginary part. That means the imaginary part is 0. So this can be even given as I. In this case, it's j. It's fine. 150 plus 0j. Over here, z is 6 minus 3j. So this is the thing. Okay. If it was the Argand plane, then 150 voltage and 0 somewhere over here at 150x. Only this is the graph. Okay. Whereas over here in this case, we had 6 somewhere over here, minus 3, it would be like this. This would be the point. Okay. The y-axis, the imaginary axis, in this case, it's 0. Okay. Now then, what is I? We just know, so I is E by Z, E by R, resistance. It's one and the same. Now let us solve this. So first let's express this in polar form. Okay. So what do we do? For E, you need to find the resistance R, sorry, it's the radius. That's find the modulus and the argument angle theta. So R is what? A and B, square root of square of 150 plus 0 square, because there's nothing, it'll be the same. And the angle is, see, this is positive, isn't it? A value is positive. So this is it. This is the formula. Tan inverse of 0 by 150. Put it in the calculator, you'll get the answer. We have done this already before. Now, what about for? Okay, this is the polar form now. This is the polar form, 150 cos 0 plus j sine 0. Now, for Z, that is the impedance or the resistance, R is square root of 6 square plus negative 3 the whole square. The value is 3 root 5. Theta is, again, the A value is positive. So this is the formula. Put it in the calculator directly over here. Let me just do this. Shift tan inverse minus 3 divided by 6. What is the answer? Over here, it's negative 0.46. Remember, your calculator must be in radians. Only then you'll get the correct answer. Next, write it in the polar form. That is the radius cos theta plus I, or now in this case it's j. That's the imaginary part, j sine theta. Okay, what next? Now we need to find the division between E and Z, right? Let's do that. So divide them. 150 is the R1, 3 root 5 is the R2. So now let's divide them. Use the formula and divide it. So all you need to do is 150 by 3 root 5. And over here the angles are subtracted. Theta 1 is 0 degrees minus of negative 0.46. Same thing in both the cases. The answer over here, I, is so much. Now, how did we get it? Very simple. This is 150 divided by 3 root 5. You'll get the answer 10 root 5. That's equivalent to 2.36. And this, you're just multiplying the signs. That's it. Now, we will write it in the rectangular form because they have asked in the rectangular form, right? They're not asked in polar form. So all you need to do is, multiply this inside. This first let's solve. Cos 0.46. Close the bracket. The answer is 0.89 over here. It's equivalent to 0.9. And what about sine? Change this to sine. You will get the answer of 0.44. Now you need to multiply this inside. 10 root 5, multiply it over here. See, all you're doing is, this is multiplied by 10 root 5. The answer in this case is, sorry, I have taken the entire thing. If I just take 0.44, it'll be a little different. It's almost approximately the same thing. See, it's 9.84. Okay. Why? Because only 0.44 is taken to multiply with 10 root 5. Same thing, multiply over here. 0.9 times 10 will be 9 root 5. This is the rectangular form. So the current is about 9 root 5 minus 9.84 J amps. So this is the answer. Not in the rectangular form. You need to convert back to not in the polar form. You need to convert it back to rectangular form and then get the answer. We will look into DeMoivre's theorem now. This is pronounced as DeMoivre or DeMoivre. Any variation is fine. If you understand the concept, that's more than enough. Now, what is DeMoivre's theorem? DeMoivre stated that if you are taking a power of any complex number which is in polar form, then you can easily write it like this and solve. That is, if z to the power n, say this is the complex number, right? Let it be 6 over here for, argument's sake. Now that means radius, you can use this. See, if you're whole powering, this will be the answer. Okay, so if you're powering it to the 6, radius must be done to the power 6, and then you need to multiply the angle with 6. That is what it means. See, that's it. So this is how we can easily solve it. If you remember this, it is very, very easy. So remember the second formula, radius will be powered. Okay, it will be raised to the power n, whereas the angles will be multiplied by the n. Now we will see a problem. You need to find the sixth power of 4 plus 4 root 3i. This is a complex number, but it's in rectangular form. You can see over here, there is no r, there is no theta. This is just a and b values. Okay. Now, what you need to do is you need to convert this into a polar form, use the power, and then back to rectangular form again. Okay, let's do one by one. We cannot use DeMoivre's theorem for a rectangular form problem. So, express it in the polar form. Now, radius would be square root of a square plus b square. Let's do it. Let's do it quickly in the calculator. It's just square root of 4 square plus, use bracket over here because there are two terms, 4 root 3, close the bracket and square it up. The answer is 8. What about the theta? It is tan inverse b by a. Let's do it. Shift tan inverse b, that is 4 root 3, now divided by a value, that is 4. Now if a is positive, greater than 0, this is it. This is the formula. Is it over? Is it done? Will I get the correct answer? I'll press equal to, you tell me. Now the answer over here is always in radians. What did I tell you? Whenever we do not have in radians, we get in degrees. No, let us shift mode and 4. Now we get the answer in radians. Try to keep this every time in radians. Why? Because if you keep in degree again, you need to convert this, that. It's a big hassle. What do I do then? I just convert it to radian mode. Now I solve it. It's 1 by 3 pi or pi by 3. Fine. Now just substitute it in the polar form. So radius, we know the polar form is r into cos theta plus I sine theta. I hope this is clear. We have done this before. So sorry for that r, it's very weird looking. Now over here r. Okay, again it's bad, but I hope this is understandable. This is r cos theta plus I sine theta. You know r and theta, just substitute over here, you will get the polar form. Okay, this is the polar form. Now is it over? No, you have not put the power. Raise it to the power 6 using the DeMoivre's theorem that says if it is z to the power anything n, so rn cos n theta plus n theta. So now over here it's power 6. So 8 to the power 6 times cos 6 into pi by 3 plus I 6 into pi by 3. All you need to do is simplify this. Now, what is 8 to the power 6? Because you need in rectangular form, right? Let's substitute. Now, what is cos 6 into pi by 3? See, pi by 3 multiply by 6, or 6 multiplied, it's the same thing. 3 one time, 3 two times. It will be 2 pi. So it's the same thing over here. It will be 2 pi, okay? So you're remaining with 2 pi over here. And now, is it over? We are still in the polar form. See, now this we simplified, but still it is in the polar form. What do we do to get to the rectangular form? Simplify this. Cos 2 pi, how much does it mean? It is 1, whereas sine 2 pi is supposed to be 0, I believe. Yes, it's 0. So cos 2 pi is 1 and sine 2 pi is 0, and this radius is as it is. Now we are converting this to rectangular form. Till over here, till this part, it's in polar form, right? Simplify this in calculators, you will start getting rectangular. Now multiply this 262,144 inside. When you multiply over here, it'll be 262,144. When you multiply anything with 0, it's 0. That means it's no imaginary part. So your remaining answer is this. So if you want to expand 4 plus 4 root 3I whole power 6, this would be your answer, 262,144. Now, I'll quickly recall first things. You need to have the equation in polar form. The complex number must be in polar form. Only then you can apply DeMoivre's theorem. So, a step one would be convert this to polar form. Once you have done that, apply the formula, DeMoivre's theorem, and then you can simplify it. Now, they have told us to get it in rectangular form. This over here is the polar form answer. But no, don't stop. You need to continue it to the rectangular form. Simplify, solve this in calculator. Everything is in calculator. Very, very simple. And then you will get this answer, which is the final, which is the DeMoivre's theorem for raising power 6 in rectangular form. We just now learned about DeMoivre's theorem. Now we will learn about distinct roots. They're similar. DeMoivre is basically taking something to the power. Distinct roots. You know this word roots. What it says is, it is the square root or cube root or nth root or pth root. You know, it can be any number. You should take a root. Now over here, this is the formula. You need to remember this, but it's simple as we break down. Now, we can only solve when the complex number is in the polar form. Look over here. You will be told, say, third root or cube root. Okay, so that means it is something like this. Okay, let me write as x. Do you know this cube root can also be written as exponent form as 1 divided by 3? This is one important thing which you must remember. Whenever you have root to something, it can be written as 1 by 3. So now if they tell you cube root over here, instead of this number, you can write anything, p. Okay, but now if they ask you 3, so that must be over here 3. And then in the angle, we don't square or root the angle. We multiply, add, or divide. So now theta will be added by 2n pi and divided by the root. This will be all 3. So now it's very simple, like the DeMoivre's theorem in the previous section, we saw that. It was very easy. But what is this extra part n? That is the extra part. Now, if I say cube root, that means there will be 3 answers for this complex number. There will be 3 answers. So now this n starts from 0, 1, for 3, it will stop at 2. Why? Because it will stop at 2, sorry. 1, 2, and third root, you will get 3 root answers. When we solve, you'll understand you need to take one case as n is equal to 0, then n is equal to 1 and 2, and you will get the answer. Now let us look into a problem. It'll be much clearer. Now find the fourth roots of -4 minus 4i. This is very interesting because a and b are same value, but they are negative. So when you find the angle, you must remember you need to add pi, and r is very simple. We have done this. Let's quickly do it. R value over here. Sorry. Now here, square root of a square, it's -4 the whole square plus again -4 the whole square. The answer is 4 root 2. Okay. Now what about theta? It is tan inverse -4 by -4, it will be 1. So I'll just write 1. But don't forget the pi plus pi over here. If you're getting confused why I've written 1, it's the same thing, right? It cancels. Because it's negative, a value is negative, I've written pi. It must be in radian mode. If it's not, press shift, mode, and 4, and the answer is 5 pi by 4. Okay, that is the answer. And now we got our question in polar form. Radius cos theta, I sine theta. That's fine. Now remember the distinct root formula. This is the formula. Here, pth root, it's fourth root. So you must change this p to 4 and rearrange and write this. All I'm doing is writing over here r to the power 1 by 4 cos, if you see over here, it'll be 5 pi by 4. That's the theta value. But what about this? 2 times n pi is in the formula, divided by p is 4. N is unknown, leave it for now. Let's simplify this as much as possible. Now over here, if you put this in calculator, now say, open the bracket, 4 root 2. They will only give you a decimal value, say this. It'll be 1.454. How do you solve otherwise is, now you have root 2, leave the power outside, okay? Leave this over here. How can you write 4 in terms of square root? When is 4 a square root? Like, how can you write it? So we know 4 is basically square root 16. Okay, how do we write this? Square this and write the square root, right? If it's 4, square it and write the square root. It is 4 square is 16. That's how we write it. Okay, so now, what else? Now you can see over here, these are two same things. You can multiply them. 16 times 2. When you bring them inside, multiply them. 16 times 2 is 32. Sorry, 32. Over here it is square root, right? 2 it is generally. And you're 1 by 4. Now if you're bringing this over here, just remember whatever is below will be multiplied to this. That's it. Whatever is below, multiply. Up will be, powered over here, but it's 1, leave it. 4 will be multiplied over here. It will be 8. 4 times 2 or 2 times 4 is 8. 32. This is the answer. Let's check the answer. We had got 1.54. Now I will take over here shift and this symbol. What is it? 8 and 32. You can see the answer will be the same. So that is the answer. Okay. And what about this? Split the denominators. We have 5 pi by 4 plus 2n pi, sorry. And now you can split the denominator. This 4 can be split over here. It will be multiplied by 4 because it's the denominator, and over here divide by 4. 4 times 4 is 16, and 2 times 2 ones are 2 twos are. You will get n pi by 2. So that's how we get this. We are just trying to simplify as much as possible. Now this is the simplified form. Okay, leave it over there. Now we need to use appropriate n values and find what? Find the roots. So first we need to start with 0, 1, 2, 3. Don't come to 4, 1 less than 4. That is 3. Why? Because it's 1, 2, 3, 4 digits now. Substitute n equals 0. You will get the same thing, but over here n, look at the n value is 0. That's the only difference. Now if that is the case, use your calculator and solve it now. It should be in radian mode. 5 pi by 16 plus 0, everything will be 0 itself. So that's it. Okay, now you don't need to do that, but you need to simplify, right? Over here, what is it? It is not polar, it's rectangular. So what? How do we get it? Here you need to put cos. Now look over here. The answer, oh sorry, this is not the answer. This is the answer for 0.55 over here. And you can write it as 0.56. Sine, what is the sine value? 0.83. Is this over? No, we need to multiply this number, this thing over here. So it will be shift and to the power 8 32 multiply with cos You can write over here cos pi by 4, but I just found the value, so I'll write 0.55. Now this is your answer. Okay, why it is 5.6? Because over here you can approximate it to 5.6, I believe. So now you will get the answer. Same thing over here, it is done. Instead of 5.6, you have to multiply 8.3. That is 1.28. Now, if you're getting much confused, don't worry. Look, 8th root 32 multiplied by cos 5 pi by 4. 5 pi by, sorry, not by 4, it's by 16. Close the bracket. That is your first answer over here. And then you need to change that to sine, because you have to multiply this inside for both, and you will get the answer 1.28. Now this is the rectangular form. Okay, so this is from polar to rectangular. This conversion, we have done it so many times by now. Same thing, you have to change it to 1. But look over here, when it is 1, it little changes. What changes is this. It'll be 5 pi by 16 plus pi by 2. So it will be pi divided by 2. And now you will get the answer 13 by 16. And then same procedure, convert to rectangular form. So this is your second answer. Same way you need to continue to do it to 2. So n is equal to 2. And over here n value only changes to 2. The same formula. And lastly we have to do it for 3. N value changes. Now, this is not difficult. If you understand one step, it is the same repetition. You have to repeat it over and over till n values are found out. It's the fourth root, so you have to repeat it so many times. So the final answer, the fourth roots are approximately, this is 1, 2, 3, and 4. So these are the answers for the distinct roots, a fourth root for this given one. And remember, we generally write the roots in rectangular form, but if you have to solve or use the formula, we have to use the polar form. Convert to polar form, apply the formula, and then convert back to the rectangular form. Now we will try to find the pth root of unity. Before we begin, you must remember unity means 1. So now, this is the rectangular form, isn't it? Let us write in terms of complex number. What is the imaginary part over here? Is there any imaginary part? No. So it will be 0 plus 0i. So this is the unity. Now what next? How would you convert this to rectangular form? Just use the formulas. This is a, that is 1, b is 0. You need to solve it as it is. Now let me solve over here. A value is 0, so square root, sorry, a value is 1, square root 1 square plus 0 square. This is how I find the radius 1. R is 1. What about the angle? Let's find tan inverse b is 0 divided by 1. It is 0 itself, but anyways, since a is positive, you do not need to add the pi. What is the answer? It's 0. Okay, now whenever we write 1, that is the complex number, in the complex form it is like this, but this is rectangular. We can't use distinct root formula because it is in rectangular form. You need to convert to polar form, and this is the polar form. Now you can use the distinct roots formula. We had just done in the previous section, so the same thing will be repeated now. Apply the formula. I hope you remember the formula. Radius r, what happens? R will be to the power 1 by p. Now which root they're asking? 8th root, so 1 by 8. That is the thing. 1 to the power 1 by 8. How much is it? Anything to the power or root of 1, it's 1 itself. It does not change. So it's 1. Now what about cos? Theta is 0 plus 2n pi. As it is, write it divided by p value is 8. So now we write 8. Same thing goes to sine, but only I imaginary part is in sine. Now let's simplify this. 0 is gone. 2 1s are 2 4s are. So you will have n pi by 4. Even at the sine, it is n pi by 4. But what about this 1 radius? Multiply it inside. 1 times, it's the same thing. Even over here, it's the same thing. So this is how we get this. Now we have applied the distinct root formula. We have got this answer over here in polar form. What next? Whatever we did in the previous section, the same thing in the distinct root section, the same thing is repeated. Now you need to find the n values. So what are the n values? N always starts with 0. The first root is at n is equal to 0. Second root is at n is equal to 1. And it goes on till p minus 1, that is until 7. So the eighth root will be 7. Why? Because we start at 0, isn't it? Now how do we find the first root? All you need to do is substitute over here instead of n as 0. Let me do this. So cos 0 means this entire thing is 0, right? It'll be cos 0. What is the answer? Cos 0 is 1. Now what is sine 0? Sine 0 is 0, right? Let's just double check it. Sine 0, it's 0. So you will get over here in the first section, when you convert to rectangular, it's 1 plus 0i. So we can just write 1. So this is the first root. Let's do the second root now. For the second root, all you need to do is, over here, this is the first root we just now found. Second root, all you need to do is, over here, we see the equation, right? Instead of n, put 1. For the third root, instead of n, put 2. That is what we are doing. So I will show you cos pi by 4, because n is 1. Now press equal to, you will get 2 root 2. Let's double check the answer. Yes, it is root 2 divided by 2. Now let's make it for sine. What is sine? It's the same thing, root 2 by 2. But over here the I remains. Now, what is the n value for third root? When it is third root, n is 2. So let's substitute over here. So cos, now we will do for sine because sine is already there. 2n is 2 pi by 4. What about the answer? It's 1. Where is it? So this is 1, yes. So now we will have plus 1i. What about the cos part? Let's change this to cos. And you can see over here cos is 0, so it is 0 plus 1i, one coefficient, you can just write it as I, right? So the 0 is gone, only I remains. That's why it's only I. In the first case there was 0i, so only 1 remained. Same way you can keep on trying for other things. Just change the n value over here. N value is minus root 2 by 2, so it's minus root 2 by 2. But when it's sine pi 3 pi by 4, it will be positive. So let's do it. Sine, and the answer is root 2 by 2, positive. Don't forget to write the I. Same thing with this. Now when it's n is 4, it's 0. So the I part is not there. Whereas cos part will be there because it is minus 1. You can do it continuously for up till 8th root. That means this is n equals 7. This is 6 and this is 5 and so on. We did till 4. This is 5, 6, 7. Let me do the last one over here. So all you need to do is 7 pi by 4. The answer is root 2 by 2. And what about sine? Sine will be over here. That is minus root 2 by 2. So these are all the roots. First root, second, third, fourth, fifth, sixth, seventh, and eighth. Okay, so the commas differentiate the root. This is how we can solve the root problem. It is by using distinct root. Most important thing to remember, whenever you have been given any question in rectangular form, you can't apply the formula. Whether it may be DeMoivre's theorem or distinct root, convert to polar form, then apply the formula. And usually the answer is asked again in rectangular form. So after applying the formula, solve it and then convert it back to the rectangular form. It will be a plus bi. This is how we solve it. So that is the end of this lesson. If you have any doubts, please do write in the comment section. And we also have come to the end of this first chapter, the first chapter in the term 3. I hope these videos have been useful for you guys. If you really found it useful, please do like these videos and hit the subscribe button. It will mean a lot to me. Thank you and see you soon. Bye bye, guys.